Namaskar, my dear friends. Today our topic is building project. Various kinds of buildings and their types, uses, building, MB regard, execution, designs, some Vasthu tip. These are various kinds of buildings, designs, and their shapes. Buildings are of mainly 8 kinds. They are Riyamish. If you remember this word, you will be in position to explain any kind of building at any time. Riyamish or means residential building or stands for residential building used for dwelling purpose. For example, this is residential building. Example, our house. This is residential building. Okay. Or over. I means I stands for institutional building. Example, colleges and research institutes, etc. A stands for assembly buildings. This building is mainly used for meetings purpose. B. Budget building, to store heavy quantity of amount. But here this is not budget building, this is business building. You call it as business building. Budget building, budget stores, budget rooms are also necessitated, but here you call it as business building, used for operating various kinds of business activities. M. Mercantile buildings. These are business complex buildings, major buildings, market yard buildings, etc. useful for various kinds of business. Next, I. This is institutional. Here I, industrial building. Example, construction companies, cement factories, rice mills, oil mills, etc. Industrial buildings useful for industrial purpose, for manufacturing of materials, products, things. These are major structures, major buildings. Next, S means storage buildings. These buildings are useful for storage purpose. H. Hazardous buildings. These are strong type buildings, for storage of certain important materials. Next, building is one of the civil engineering project. It protects us from rains, heat, thieves, and it also protects our assets, luggage, and materials. MB record. For recording MB, you come from top to bottom. Top means parapet wall to foundation. For execution purpose, you go from bottom to top, means foundation. Before the laying of foundation, you have to clear jungle clearance. Jungle clearance means site clearance, foundation. Next, bed, footings, columns, plinth beams, slabs, lintel beams, etc. Then parapet. After that, compound wall, gate, etc. Next, designs. For designs purpose also, you go from top to bottom. Parapet wall to foundation, footings. Vasthu. This is pure health science come engineering aspect, engineering subject, civil engineering subject. For example, a tree in east direction will obstruct the sun rays, which is the cause for bone diseases. for occurrence of bone diseases. Tree in west side will give shadow to our house and protects the building and it makes us and our building cool and happy because the shadow comes to our house from back to front. This is the benefit of Vastu. There is no superstition in it. This is pure health science come engineering principles, engineering subject. Now, design of buildings. Design purpose. Go from slab to foundation. This is about slab design. Design of a RCC continuous slab with the following data. This is the continuous slab. S1 room 3 into 3 and 3.5 meter. This is S1 means slab 1. If there are 4 slabs, you name them as S1, S2, S3, S4. Like this, you name and design. Bearing on both sides 230 mm. That is wall thickness support equivalent to wall thickness or support. Live load LL 2 kN per mm square. It varies from structure to structure. For example, for temple, you have to take more load. You follow building manuals and IS 456 code. 2 kN per meter square. Next, floor thickness. Here we adapted M15 grade of concrete and Fe415 steel grade. Now you adapt 500. Here you take M20. Now this is golden type building. C is equal to stress in concrete and T is equal to stress in steel. This is 5 Newton per mm square. This is 230 Newton per mm square. 15 by 3 is equal to 5 Newton per mm square. You get 5 Newton per mm square. T is equal to stress in steel. M is equal to 280 by 3 sigma BC. C is equal to stress in steel. 3 5s are 15. 280 by 15 is equal to 18.67. N1 is equal to neutral axis factor. J is equal to lever arm. 1 by N1 minus 3. N1 is MC plus T. This is N1. M is modular ratio factor. See, this is 18.67 into stress in concrete by MR factor. MC means 5 plus T. Stress in steel, that is 230. This value is 0.29. J, lever arm factor, LA factor, 1 minus N1 by 3. 1 minus 0.290 by 3 is equal to 0.903. Q is equal to MR factor, moment of resistance factor of CJN1. This is 0.65. Assuming overall depth, D is equal to overall depth. Small d is effective depth. D, capital D minus half of the diaphragm minus clear cover. Effective depth is equal to this much. That is next, effective span is equal to clear span plus 2 into half support. Clear span plus D, whichever is less or lesser. This is 3.1 meters. LE is equal to 3.1 meter. Slenderness ratio, SR ratio, R is equal to LY by LX. Therefore, R is equal to, we got R is less than 2. Design the slab as 2-way. 2-way slab acts in 2 directions. So, we provide main steel in 2 directions. In 1-way slab, it acts in 1 direction. So, we provide main steel in short direction, and in long direction, we provide distribution steel. See, this is Grashof-Rankin's method. Case is good. You follow building manuals. R to the power of 4 by 1 plus R to the power of 4. Here we got 0.64. Next, calculate this. Here, unit weight, remember, floor finish unit weight 24 kN per meter square. For RCC, 25. And for CC, you can take lesser value, that is 22 or 23 kN per meter cube. Next, loads. Dead load, live load, floor finish is equal to total load. This is dead load. Dead load on the slab. See, dead load of the slab is, our thickness is capital D is equal to 0.12 means 120 mm into 25 kN per meter cube. That is equal to 3 kN per meter cube. Here we have assumed as 120. Slab thickness is 120. FF 20 mm, assumed as 20 mm. 20 by 1000 into 24. For PCC, unit weight is 24. For RCC, 25. This is 0.48. Total worked out to 5.48 kilonewton per meter square. Therefore, W is equal to 5.48 kilonewton per meter square. For design of slabs, you always calculate the loads per meter square. For beams, meters per meter length. For columns, in kilonewtons or newtons. Again, I am telling you, remember, note this. For slabs, take and calculate the loads per meter square length. For beams, per meter length. For columns, calculate the total load acting on the column that transfer to the foundation in kilonewton or newtons. So here D is equal to root of m by qb. M is, we got this value, see, maximum design moment. Mx is equal to 3.38 kilonewton from this formula. See, in long span y direction, W into Ly square by 10. In short span, W into Lx square by 10. This is 3.38. Calculate. This is 100 mm. Okay. Now spacing. Calculate this spacing. AST is equal to m by tjd. AST is equal to m means maximum bending moment. T is 230 stress in steel. J is lever arm factor. Next, m by tjd. D is effective depth. Means up to the center of the bar. The depth up to the center of bar. Remember one point here. Clear cover for slab, you always take 15 mm. For beams, 25 mm. For columns, 40 mm. For footings, 60 mm or 80 mm. Okay. This is about clear cover. And here, this is about design of slab. Simple. Dead load, live load, floor finish. That is total load. Moment is equal to WL square by 8. D is equal to root of m by qb. AST equal to m by tjd. In respect of some typical buildings, heavy buildings where wind load is heavy or earth load is considered, then loads are to be modified and take another extra factor of safety. Okay, next. Spacing of bars calculated here. See. This is about spacing of 8 mm dia bars. Pi by 4 into d square. Circular formula. Bar shape is circular. So, circular formula is 5 by 4 d square pi by 4 into 8 square is equal to this is spacing. 340 mm center to center spacing. But we have rounded and limited it for factor of safety 250 mm center to center to improve bond between steel and concrete and for factor of safety. Next, check for shear. Shear force is WL by 2. W, this is load 5.5. L is 3.1. Effective span by 2, 8.52 kilonewton. Shear force unit is kilonewton. B is equal to 1 meter, 1000 mm. D is 90 mm. Effective depth here, 90. Next, TOV, nominal shear is V by BD. We got this value. And from IS 456, 1978, now 2000, IS 456, up to 0.25% is 0.22 Newton per mm square for M15 concrete. TOV is 0.095. TOV less than 2C and safe. Now check for bond. Bond is also very important. Bond between steel and concrete. Bond means bandham. Here TOBD less than TOBD maximum. That is 0.695 Newton per mm square. That is 0.84 Newton per and safe. Form wise, see here. TOBD is equal to V by A sigma O. V shear force, J lever arm factor, D effective depth, N means number of bars per meter, and then pi into D means dia of bars. From this you can calculate this value. Check for stiffness. Stiffness is also very important. Limiting stiffness for continuous slab is 26. You take from table. AST is equal to this area. P is percentage of steel we have calculated earlier. That is 0.2%. Modification of factor MF it is 0.2%. That is 1.0. Refer IS 456 table and graphics. D required for stiffness. LE by stiffness value into modification factor, my dear friends. LE is 3.21. LE Capital L is called clear span between the support, length between the support. L is effective span, means center to center of support. Okay, center to center of the supports. 3.1 into 1000 by 26 into 1.6. 1.6 modification factor taken from the table. Stiffness value is 26 for this continuous slab. Okay, this value is 74.52 mm. D available 90 mm. D required is less than D available and safe. Next, design of beams. Take all the loads per meter length. Okay. Self weight of beam, dead load of beam, next live loads, and next any other loads consider. Means tanks, water tanks, etc. If you provide any water tank on southwest side on the roof, that load will also be considered per meter length. Maximum bending moment. This is formula MB. And next, effective D required, root of M by QB, M maximum by QB. Okay, this is about beam design. Loads, these are the loads: slab load, beam load, and next live load. This is the total load. Next, check for shear. This is shear check. This is cross section and plan of the beam. Length, width, reinforcement. These 3 bars. Look at this picture. 2-legged 6 mm dia bars provided 250 mm center, 2 numbers 10 mm dia bars, and 2-legged 6 mm dia 200 center to center here. From section to section, reinforcement varies and size also varies. Breadth and depth. This is 410, 240 mm, 250, 490. Depends on the loads. Next, design of columns. For columns, you take the total loads acting on the column. For example, say this is the room size, 3.3 into 3.6 meter inner dimension. Wall thickness 0.23 meter. Slab thickness 0.15 meter. Height of the wall 3.3 meter for ground floor and 3 meter for first and second floor. Roof beam size 0.23 into 0.42. Plinth beam 0.3 into 0.35. Column height 3.3 meter and 3 meter height for first and second floors. PCC unit weight 24. RCC unit weight 25. And unit weight of brick masonry is 19.2 kilonewton per meter cube. FF floor finish is 24. And thickness is 20 mm. Angle of repose of soil 30 degrees. Bearing capacity of the soil is 150 kilonewton per meter square. If it is hazy soil, this is 250. If it is rocky soil, varies from 250 to 350, 450, etc. For BC soil, you take 10 kilonewton per meter square to 12 kilonewton for some soils, 5 to 6 kilonewton per meter square also, where the foundation to be treated with the coarse sand and other layers. And this is about column design. Toe bead is bond stress here. T is safe stress in steel. You take 190 Newton per mm square for Fe 415 grade steels. C is safe stress in concrete. That is 4 Newton per meter. Direct in compression, not tension. Direct in compression, it is 4 instead of 5. This is 190 instead of 230. Okay. Follow building manuals and IS codes and model designs of various departments. This is slab plan. This is column. This vertical member is column. Horizontal members called as beams. This is the load diagram. This is bottom horizontal layer is plinth beam. This is column. This is load figure, load map, load picture, where the total load is acting at this point. H is less than 2B here. Wind load is neglected. If H is more than 2B, then consider wind load, where P is wind pressure, kg per meter square. V is velocity, kilometer per hour. K is coefficient, that is 0.006 decided by NBC. Wind load in this case is nil here. In our case, it is nil, not taken, because there is no wind effect. Okay. This is about next end column, side column, pillar column. There are three kinds of designs of pillars. Next, lateral ties. Die of the bar is less than 1/4 of the die of the bar, that is 5 mm. But practically 5 mm not available, we provide 6 mm. Next, pitch of the ties should be the least lateral dimension, that is size of the column, 360 mm. 16 times the die of bar, that is 320 mm. 48 times the die of the ties, 48 into 6, that is what? 288, rounded to 285 mm center to center. Therefore, provide 6 mm die ties at 285 mm center to center. However, we have limited it to 250 mm center to center for factor of safety. Check for minimum eccentricity. Is eccentricity small e. Unsupported length of column by 500 plus size of column 30. 3.3 by 500 plus 360 by 30. That is equal to 18.6 mm. E limit is 20 mm. So this 18.6 is less than 20 mm. E less than E limit, hence safe. Next, check for load carrying capacity. Check for load carrying capacity. It is also checked. This is safe. P is equal to AC into C plus AT into T. AC is area of concrete, C is stress in concrete, AT is area of steel, T is stress in steel. This is the formula. Safe load is more than actual load. That is 752.13 kilonewton is safe load, 659 kilonewton is actual load. So this is more than this and safe. Our structure, our design is safe. This is the building project designed by me and given to various students who are involved in various kinds of project works. Okay. So this is footing, this is column, but practically you provide like this footing, sloped footing. For footing design also, see footing design, P is equal to axial load on column and size of column 350 into 350 our size. This is footing, see mats, plan, footing reinforcement, column section, this is column section. Area of footing is equal to W by QC. W is 724.95 kilometer. 659 column load plus 10% of this load, that equal to 724.9 kilonewton. This is footing load assumed as 10%. So this plus this. Okay. Next, effective depth. D is equal to root of M